Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials V6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 1.1.3.5, where we're now going to get a chance and an opportunity to configure some IPv4 and IPv6 addressing on interfaces. So let's jump into the Packet Tracer activity. You can see we've got a pretty diverse setup, and it seems like everything on the left-hand side is going to be IPv4, while everything on the right-hand side is going to be IPv6. So here are the objectives. We're going to be configuring IPv4 addressing and verifying connectivity and doing the same for IPv6. We have our addressing table here at the top that's going to lay out all of the addresses that we're going to be using. And routers R1 and R2 each have 2 LANs. And your task is to configure the appropriate addressing on each device and verify connectivity between the LANs, which means we're going to be going across the internet here and confirming that. So let's configure the IPv4 addressing first. So referring to the addressing table, which is up here, configure IP addressing for the R1 LAN. Well, let's just go ahead and as we read from left to right, let's go ahead and configure from left to right here. So we'll start with PC1. This is some low-hanging fruit, pretty straightforward, and we can see the PC's address. It's using a Class B, as in Baker, Class B address, but the address has been subnetted down to a /25. And we'll talk about that here in a second. So let's go ahead and go to the desktop, and here's the IP configuration tab. And we are going to be using a static address. So the address is given to us. This is pretty straightforward. So 172.16.20.10 for PC1. Now you'll notice when I hit the tab key, and this is pretty much universal on Windows boxes, it does this all the time. You'll notice it put in a 255.255.0.0. It put a /16 subnet mask in here auto-magically for us. Now the reason that it did this is because it recognizes that that 172.16 is a Class B address. So in order for us to subnet it down to the /25, we need to come in here and make some changes and say 255.255.255.128. Now the default gateway, which will undoubtedly be the interface right here, that'll be the IP address on this interface of router 1, is going to be, and they give that to us, it's 172.16.20.1, and DNS, it doesn't look like DNS is in the equation here, so we can leave that off for now. And as you can see down in the lower right hand corner, we've just picked up 5 points. Now if I was to ping something, so can I ping that default gateway? Now by looking at the diagram, what do you think? By looking at our network diagram here in the upper left, is this ping going to work? And typically when you see red like this, the answer is going to be no. So again, if I was to say ping 172.16.20.1 to test the connectivity to that default gateway, you can see that's what is going to happen here is the requests are simply going to time out. So we'll come back to that. All right, now we're not doing anything with the switches. So the switches do not appear, or I should say from an addressing standpoint, the switches don't appear to have any IP addresses. I'm just scanning the activity here briefly to see. Okay, so let's go, and my guess is that we may have to no-shut the port on the switch, but I'm going to step to the router as we continue to move left to right, and we've got a little more room here. So let's slide this down and let's bring this up a little bit, right about to there. All right, so now we're on the router, and you can see we're being asked for a password, and it's right here in the background. The user exec password is Cisco, the privilege exec password is class, and so I'm going to go ahead and say, whoops, I'm going to go ahead and say class, and class doesn't work. let's try Cisco, and Cisco works, right? So Cisco is our password to get logged in on the console line. Now, we are in user exec mode. The greater than sign is the indication of that. So we're in user exec, we need to use the enable command to get into privilege exec mode, and this is where we're going to use class. And so you can see the pound sign or the hash sign is the indicator that we are in privilege exec mode. And this is sort of like a launching point for us to now go into global config and make address configuration changes. So on router 1, let's get into global config with configure terminal or conf t. And then we're going to configure the interfaces as they are listed up here in the addressing table. So first things first, we're going to go to interface gigabit Ethernet 00, where I'm going to say IP address, and this is that default gateway address, 172.16.20.1, and the subnet mask is that /25, right? Or the first 25 bits of the subnet mask are dedicated to the network portion. Because again, we've created two sub networks here out of a single, what was a /24, we're cutting it into two /25s, one for each interface on the router. Okay, so let me take a quick look up there. Yep, that's it for that. So we've got the IP address. Now, what else do we need? If I say do show IP interface brief, remember I need to put the do in there because I'm trying to run a show command from the interface configuration stanza. So I can't do it by just simply saying show IP interface brief. That's not going to work. I need to say do show IP interface brief. And what do we see here about these interfaces that we're working with? It's probably going to be these two gigabit Ethernet interfaces off of router 1. Well, we see that they are administratively down, and hence we've got these red dots here, right? And that's typically what you're going to see is that the interface is down. So we say no shutdown, or you could shorten that to simply no shut. Now, you can see that the interface came up, and as I suspected, it doesn't appear that there's going to be anything to do here. The switch, this switch here, or I should say all of these switches, 1, 2, 3, and 4, are just pure layer 2 switches. We're not interested in managing those switches. And when I say manage, I mean via an IP address on this network. So, and again, I don't see any switching information there, so we'll leave that off for now. So we bring the interface up, and we're good. Now, always good practice. We're not going to get any points for this, but always good practice. And let's just say interface, put a comment on here, to LAN 172.16.20.0, whoops, 0.128.25. There we go. And again, you could put your name in there, maybe the date that you made the change, brought the interface up, but always a good idea to put a comment and a description under each interface. So now let's go ahead and get into interface gigabit Ethernet 01, where we're going to do much the same thing. We're going to say IP address 172.16.20.129, and this is also the first usable IP address in that range. And so the subnet mask, again, is the same. So what we did, and let me expand on that comment. I want to make sure I don't gloss over any of the details here. So this 172.16, whoops, 172.16.20.0/24. So that was the original subnet. And so we figured out here over on router 1 that we're going to have two mutually exclusive, right, two individual subnets, that these PC1 and switch 1 and PC2 and switch 2 would be on their own networks. So we said, okay, we've been given, right, and I'm kind of assuming here that we've been given this /24 and been told, okay, make it work, but divide it into two. Well, in order for us to do that, we're going to simply have to borrow, right, one of the host bits in the last octet, because a 24 looks like this, right? 255, whoops, 255, 255, my pen is kind of giving out on me here, 255.0, which means that these are all ones, the 255s are all ones, and then the 0 is 0.0, or I should say dot, 0.000000000, 8 zeros, right? So we come into this last octet because I'm like, okay, I've got to borrow one of the host bits. And so 2 to the number of bits borrowed, and let me do it up here where it's a little cleaner. So 2 to the number of bits borrowed is going to give me the number of networks I've created by borrowing that bit. And that leaves me with 7 host bits. So 2 to the 7 minus 2 is going to give me the number of usable IPs. In this case, it's going to be 126. Yeah, 2 to the 7 is 128. So it's going to be 126. So we borrow that bit, and instead of a 24, we get a /25. But now we need to know about the block size, right? In other words, we still start at 172.16.20.0, but we've borrowed the bit, and the block size is 128, right? And we know the block size based off of the value of the first bit that was borrowed there. So if it's 128, that means that the next network is going to start at 172.16.20.128. So the first usable is 129, and the same thing here. The first usable here is .1, and those are the 2 addresses that we are using for our default gateway. So that's how we ended up here, right? That's why we've got 2 different subnets. All right, so we enter our IP address and our subnet mask in. And then we're going to say no shut, and that's going to bring that interface up. And then we'll put a quick description on here. So you could say, you know, CCR number, the change control number that you use to do this, and we'll say 8675309, and TP bond fee, and I did it on 01/27/2018. That way somebody following you is going to have an idea as to what it was that was done, right? They can go back and reference the change control ticket, right? They can see that it was done on this date, and then they could simply come ask you and say, hey, what were you doing? Why were you doing this? All right, so we've got that set. So now if I come back over here to PC1 and we run the ping command, now it works, right? Because we've brought that interface up on the router. So now let's go ahead and sort out PC2. And PC2 static IP is 172.16.20.138. Let me make sure I got that right, 138. And again, it auto-magically fills in that /16 that we need to change because we're subnetting. And we now know that the default gateway is 129, the first usable IP in that subnet range. So I can close that down. I'll pull the command prompt up, and can we ping 172.16.20.129? Can I get my default gateway? I can. Can I ping the default gateway on the other side of the router? I can, right? And can I ping PC1 172.16.20.10? Absolutely. So we have vetted connectivity on the left-hand side. Let's see if we can get all the way out to the dual stack internet server. So when I say ping 64.100.1.10, and we may have to ARP out here, can I make it out there? So the first request times out, and when I say it has to ARP, right, that means it has to send an address resolution protocol packet. And what that means is, it means that we're on PC2 here, that means that on PC2, when I typed in ping 64.100.1.10, what PC2 does is it looks into its ARP cache, and it says, do I have an entry? Do I know about this network? Do I know how to get there? And it clearly sees that no, it does not have, and I shouldn't say in the ARP cache for the entry, what it does, it looks in its networking table, and it sees, do I have a route? Do I know how to get to this network? And it says, no, I don't, and therefore, what do I need to do? Well, I need to get to my default gateway. That is the purpose of the default gateway. So when we type that command on PC2, PC2 says, do I know how to get to 64.100.1.10? Is that something that I locally know about? I don't. So then it fires out an ARP packet, assuming that it didn't know about its default gateway at that point, and it'll time out after, I think, 300 seconds. So it sends an ARP packet out saying, hey, I need my default gateway layer 2 address. And I know my layer 3 default gateway address because it's configured right here. So it sends this ARP packet out that says, hey, I'm trying to get to 172.16.20.129. If you're out there listening and it's broadcast out to everybody on this network segment, right? If you're listening 172.16.20.129, please respond back to me with your layer 2 MAC address information so I know how to forward the packet. And then the packet makes it to the default gateway, and the default gateway at that point, the router is now responsible for routing that traffic out. So again, PC2 recognizes it doesn't know how to get to the 64, 100, 110, that it's not a local network it knows about, that it does not have a route configured to get to that network. It sends an ARP packet out. Again, if it didn't have an entry for router 1 in its ARP cache, it's going to send an ARP request out, broadcast to everybody listening saying, hey, here's the default gateway address I'm trying to get to. If you're the default gateway and you're listening, please respond back to me with your layer 2 MAC address information. And then from there, the packet gets forwarded to the default gateway and then out to the internet where routers sort of take over and make all the magic happen. All right, so we are at 50 out of 100, which tells me that once we finish up over here, we've got half of the credit for the IPv4. Now we'll do the IPv6 side of the house. All right, so now we're going to take a look at the left-hand side of our equation over here. So let's go ahead and configure PC3. So we'll put our IPv6 address on here, 2001 DB8 CODE colon, and for PC3 it's going to be 12::A, and it's a /64. The link local we're going to leave the same. The gateway, which is given to us, is going to be FE80:::, ::2, right? And so we'll enter that in. And we can't ping anything yet. We know that because we've got these red dots right there. So I'm going to stretch this out. And then let's come down here. And let's jump onto router 2. And we're going to use Cisco as the password to get logged in on the console line. And now we're in user exec mode as indicated by the greater than sign. We're going to say enable to get into privilege exec, and the password here is class. So now we're in privilege exec as indicated by the #. Let's get into global config, and now very straightforward, just like on router 1, we're going to come over here and say interface, gigabit Ethernet 00. I'm going to say no shut right out of the gate. We're going to bring that interface up. I'm going to say IPv6 address, and it's 2001:DB8:CODE:12::1/64. Now, you'll notice it doesn't have a link local address indicated here. So let's see, by saying do show IPv6 interface brief, you can see that the link local is already here now. It won't be there, it won't look like this, it'll be like a random string like this. And we'll talk about the EUI64 down the road as to how it auto-magically generates a link local address. Remember what I said, you have to have a link local address with IPv6. You don't have to have a global unicast address, but you do have to have a link local address on every IPv6 interface. All right, so we already have the link local, so we're good there. We did our no shut. We could put a description on here, right? I'll just say ABC134, and then we'll go into interface gigabit Ethernet 01, where we're going to say no shutdown. The interface comes up. I'm going to say IPv6 address is 2001:DB8:C0, and did I say C0 on the other one? Okay, C0DE, and then colon 13::1/64. So now we're good there. Let's say on serial 001, you can see they kind of, a little tricky here, they give us a link local for serial 001, and then they give us the address, which is not the IPv6 link local address that we have. So let's go ahead and take care of that in interface serial 001 and say IPv6 address FE80::2 link local. So that knocks out that part. So now we have a link local address configured there. So I should have connectivity now from PC3 at least to my default gateway. So let's say ping 2001:DB8:CODE:, is it 11? It's 12. 12::1. So can I ping my default gateway? I can. Now, can I get all the way out to DB8, and it's going to be 100:1::A? And take a look at that. I can get all the way out to that dual stack server. Can I get to PC4, which is going to be 13::A? And the answer is no. Why not? Exactly. We haven't configured PC4 yet. So let's come over to PC4 and let's drop in that IPv6 address, 2001 DB8 colon and CODE colon 13::A. It's a /64. And the default gateway is FE80 colon 2, that link local. Remember, we say that they're link local because they have link local scope. They are local to the link on which they are configured. And this is why I can put the same link local address on every interface on the same device. Excuse me, so I'll explain that in a second. So you can see here we've got reachability. We got the other 50 points. And what I mean by that link local comment is you'll notice that every interface on the router is FE80 colon 2 for the link local address, because it's only here on this segment that matters. It doesn't matter between the interfaces on the router, right? They can all be FE80 colon 2 because it's only on that link and this link right here, right? That's it. It doesn't route link local addresses. They do not route, right? So if I had another host hanging off of here that went to this router and then to this router and then to this router, and then we've got the host over here, the link local could be FE80 colon 2, FE80 colon 2, right? If that was router 2. If this was router 3, it would be FE80 colon 3, FE80 colon 3. And if this was router 4, watch what I could do. This could be FE80 colon 2, and this could be FE80 colon 2, as long as this is not FE80 colon 2. So they're local to the link. So even though I had 2 and 2 and 3 and 3, I can then say 2 and 2 here, as long as this is not 2, FE80 colon 2. So they don't route, right? They are local to the link. And that's what that means. All right, so we got the other 50 points. We've got everything configured. We tested our connectivity. Everything works great. And so that is going to wrap up Packet Tracer Activity 1.1.3.5, where we learned how to configure IPv4 addresses. We talked about descriptions, and we learned about configuring IPv6 addresses. And I'm really thrilled to see that this has been included early on in the course material, that they're bringing IPv6 in right away, because there is no question that IPv6 is growing in use, right? It's becoming more and more adopted. So that is it for this Packet Tracer Activity. I thank you guys so much for watching, and I will talk with you soon. Have a great weekend.